Hello, home mechanics. So my name is Matt, and this Honda Accord here, 1989 Honda Accord, has a problem where the fuel gauge always reads full. So what we're going to do is go ahead and replace the fuel sending unit, since that's probably the issue. So let's go. Okay, I hope you know I was joking there, right? We're not just going to replace the fuel gauge sending unit without testing to make sure that that's the problem, okay? Because otherwise we'd be idiots, right? Okay, just checking to make sure that you knew I was joking. All right. All right, so brief history on the car. This customer is a referral from another customer. This guy, really nice elderly gentleman, had the car forever, and I'm doing a whole bunch of stuff for it because he's on a fixed income. Leak at the fuel rail. This is kind of interesting. 3 of the 4 motor mounts are broken. How about that? That's pretty cool. But also in the interim, with visiting him in his house and helping to put together what we need to do, I noticed that his fuel gauge was always full, and he said it's been that way for at least 7 or 8 years. So what we're going to try to do is get a diagnosis of what's wrong and see if I can fix it without buying any parts, because the idea is I want to just try to surprise the guy by returning his car good as new and say, oh, by the way, I also fixed the fuel gauge for you, and just kind of surprise him as a little goodwill kind of thing. So that's kind of the objective today. So hopefully we can do that. But it all starts with finding out why the gauge is always reading full. So let's go ahead and start with just a simple reproduction of the situation. You can see our fuel gauge there. Let's go ahead and just turn the car to on. And it doesn't budge. I don't know how much fuel is in the tank right now. I know it's definitely not full, but no matter what we do, the gauge does indeed read full. Very, very common problem. So what I want to do is see if there is an access panel to the fuel sending unit in the trunk, because that's going to be the most accurate place to do our diagnosis. This dude seems rather active for an elderly guy, I must say, but I always hate it when there's like 10 billion things in the trunk. The last time I had to do a fuel pump, the guy was preparing for the zombie apocalypse out of his trunk or something. But let me get this all cleared out, and I'll show you what we're looking for, because the whole idea here is we want to diagnose, is this a problem with the fuel gauge, with the sending unit, or with the wiring, or a combination of things. So let's see what we can find here. All right, fortunately for this guy, there are these access panels here, but this one is going to be for the sending unit. And I must figure out what this goop that they use to seal these up is, because it's powerful as hell. But the guy's very fortunate that there is this access panel, because that means I am going to be able to do my testing without dropping the tank. On some models, especially like GM, you would have to drop the tank to test sending unit. And if that were the case for this guy, that I would have to drop the tank, then that would of course mean that I would have to tell him his fuel gauge will remain broken. But let's go ahead and unplug this. And what I'm looking for, because I actually did, I think I did, I found a wiring diagram here. And what I'm looking for is a yellow and white wire, because it looks like this is going to be a very simple design where we've got the battery positive coming through the fuel gauge to the sending unit. The sending unit, of course, is going to be a variable resistor, like as far as I know they all are. And it even tells you that when we're full, we're at under 6 ohms, and empty over 100 ohms. So basically when the fuel tank is full, there's a float, and when the float is floating high, there is minimal resistance through the gauge, so the gauge is going to read full. And conversely, when the gauge is reading empty, it is because there is maximum resistance, because the float is lower, and the lower you go on the variable resistor here, then the more resistance you get. Based on the fact that the fuel tank is reading full and the information I got from hopefully this correct wiring diagram, with the fuel gauge reading full the whole time, we know we must have one of several problems here. Either the fuel gauge itself is stuck at full, there is a short to ground with the power wire. Of course, a short to ground would create no resistance. The gauge will read maximum then. Or some type of issue with the variable resistor where there's either a short to ground again or some bypass of that resistor. Were I not making a video, I would actually go ahead and just pull this sending unit out and start goofing around with it to see if I can make it work on the gauge. But we're going to do this a little more technically, assuming that in your case it's not so simple to get the sending unit out there and just test it manually. And obviously one of the first things normally you would do is check the fuse, but again, I'm not worried about an open in this circuit, because if there was an open, there would be infinite resistance. The gauge would most likely be reading empty. So what I want to do is find my yellow and white wires. So let me clean these up a little bit, because it looks like there's a couple of choices for wires here, and they all look the same because they're dirty. All right, I want to do one other thing real quick here. Now that I unplugged the sending unit, I want to take a quick look at the gauge and hope it reads 0, or empty, I mean. And check that out. It does read empty. So what does this tell us? Well, this tells us that it's very, very unlikely that this problem is with the gauge. It's very likely that this is going to be with the sending unit in the tank, that maybe the sending unit is stuck in the full position or some short to ground or something like that. But the fact that we move down the gauge to empty means that the infinite resistance from the open is detected by the gauge. But I still want to do one more gauge check just to 100% validate that the gauge and the wiring from the gauge to the unit is indeed working. All right, now after cleaning up these wires, I see that we don't have anything that really remotely resembles this wiring diagram, which is the norm. One of the many reasons I really don't like working on cars that are really that old. It's just hard for me to find good information on them. But what I'm going to do is just figure this out myself. All right, what I'm going to do to measure is, let's see, it looks like we've probably got, that looks like black there, so it looks like we've probably got our ground there. And then let's see what we've got here, because this is nothing like the wiring diagram. We've got 6 volts there. And there's our power. There's 12 volts, and that is on a red and green wire, which is nowhere on that diagram. So yeah, the hell with that diagram. So what I think this system is a little more complicated, but that's all right. What I want to do is my brilliant idea here, which I may come to regret, but I do believe this is going to work, is I want to sort of play the part of the fuel sending unit by creating a resistance between, I can do it between the ground and the signal wire, actually. So let me go to my little electronics kit and see what I got. What I did find is a resistor. I have no idea what these markings mean. I am a molecular biologist, not an electrical engineer, but I'm pretty sure, because I remember getting these for some other thing. This is probably like a 50 ohm or 35 ohm resistor or something like that. But the point is that if I put this resistor, to put resistance on that signal wire, so I can do that actually between the ground and the signal wire here like this, make sure that that has a connection. What this should do is move my fuel gauge. And I guess if that wiring diagram were right, we would expect the gauge to show 3/4 full, I suppose, because if we do 33 ohms resistance and 100 ohms would be empty. But this resistor also, I believe, is a 1/2 watt resistor. So, but actually there's good news. The fuel gauge did move, so let's take a look here. All right, so we can see on our fuel gauge that it is now reading, well, just a little over 1/4 of a tank, almost half a tank, and it might actually still be increasing a little bit. But the bottom line is this tells us a number of things. First of all, it tells us that the gauge does work. It does tell us that the wiring integrity from the gauge to the sending unit is good. And basically this means that whatever the problem is with this fuel gauge not reading accurately is going to be a problem with the sending unit. So that means we are going to have to get that sending unit out of there, and let me go ahead and do that and see what we find. And here is la pièce de résistance. Ha! Get it? Sorry, I couldn't resist. Ha! I did it again. All right, but anyway, so this is, let's see, how does this go? That will go into the tank. This, of course, is our float here, and as that float increases, inside of here is a variable resistor. So at full, we should have minimal resistance, and at empty, you would have maximum resistance, and that is how this works. So what I am going to do to test this thing is let me go ahead and set my voltmeter up here. All right, got some alligator clips here, and let me think here. Well, I know one's going to go to ground here. Well, first of all, let's make sure. Yep, so our leads are good. And one's going to go to ground here, and let's see, I want the other guy to go to signal. And I believe that's this one, I'm pretty sure. All right, let's see how our meter looks. So right now it is reading 106.5 ohms. So if I move this, we should reduce the ohms. And it does come down. Well, it's kind of jumpy, isn't it? Maybe, let's see if we can just hold it still here, put it in a better position. There, let's try that. Okay. Let's see, we're at 35 ohms there. And 105 ohms there. And interesting, 26 ohms there. So it does seem to be proportional until we go, well, now it is working better. So maybe there is some kind of internal fault there. There's 6 ohms, which is interesting, by the way, because that's what that wiring diagram indicated, was 6 ohms at full, which this position would be. And I'm not going to say that this is the easiest to move. It's kind of squeaky, maybe takes a little more effort. So maybe it won't fall down on its own. Now it does. It falls down plenty easy on its own, so it shouldn't have a trouble measuring the fuel source. So maybe it was just in a stuck open position or something, but what I may do is see, it doesn't look like I can take this apart very easily. Let me try taking that apart and see what's happening inside of there. All right, I'm just not totally comfortable with the consistency of those readings. All right, so there's our variable resistor, as you can see, I hope. Let's see if that's in the camera. There we go. Okay, let's get that in a good position there. So now we're at our empty position, 115 ohms, and our full position. I'm still not liking how that doesn't go to like 6 ohms. And there we go, now it's at, yeah, not really liking that very much at all. I wonder if I can maybe try to clean this up a little bit and see if we can maybe get a little better consistency with the reading. All right, little electrical contact cleaner, a little lubrication up of the switch, and let's see where we're at now. Right now we are at a full position, and it is reading about 7 ohms, which I really like. And then now let's move this down, and there's our 115 ohms, and as we move the switch, we see we get actually fairly instantaneous response now, and then back up to empty again where there is no resistance. I like that a lot better, way better. That's much more consistent. So every indication is that this should work, but we can do another very simple test now that we've got this out of the car. Let's go ahead and hook this up to the fuel gauge and pretend that we're now the level of gasoline instead of the resistor and see what happens. All right, we're fixed on the fuel gauge there, which is at empty, of course, because we've got infinite resistance. And what I'm going to do is go ahead and plug in this fuel gauge. All right, we're plugged in, and we should be at the full position now. And so that gas gauge should start climbing up to full, and it may take a while for it to do that. All right, excellent. We can see that it's definitely climbing up to full, and I'll maybe go ahead and give it a minute off camera because it does take a good 20 or 30 seconds for it to start moving. But let me move it to halfway now. All right, now it's set to about half, and so the gauge, we can see it is dropping, and as long as it stops somewhere around half, and again, this is kind of slow to react, so it's taking a good 20 or 30 seconds, so I'll just pause when it settles. And all right, I'm pretty happy that that's about, it's kind of hard to tell what halfway point is exactly. And let me go ahead and set it down to about a quarter of a tank full. All right, so now I've got it set to about a quarter of a tank, and we'll see if it settles down. I'll pause it because it's a little slow, but we'll see if it stops at around a quarter of a tank or so. All right, and there it is, right about at a quarter of a tank. So this does look like a fix. I'll go ahead and reinstall it, and we'll see what happens. All right, I've got the sending unit installed, and let's go ahead and take a look. There's about a quarter of a tank of gas, it seems, in the tank, and we are just a bit over a quarter of a tank there. So this is apparently a fix. Awesome. Well, certainly among the many satisfying things about spending my weekends doing this, one of them is, of course, helping this old guy with his car and surprising him with the fixed gas gauge now. I'm sure that'll be a really pleasant surprise for him. And also, of course, the little trick with the resistor was actually kind of cool, I think. I really like that. And those are two of the things that really kind of keep me doing this, and actually not necessarily in that order. But thanks for watching. I hope you found this helpful.